Hello everyone, myself Dr. Deepa Bevingida, working as Associate Professor in S.G. Palekundri Engineering College, Belgavi. Today in my video, we are going to study numerical methods. I will be explaining what is a numerical method and what are the methods. Here we are studying two methods. One is Regula Falsi method and Newton-Raphson method. Before taking actual methods, let us discuss what are numerical methods. So numerical methods are very important tools for engineers and scientists. Even we can solve by using analytical methods, but there are limitations for analytical methods. Next comes graphical method. Graphical method is simple, but it gives a low degree of accuracy. So numerical methods give very good accuracy in calculating. So numerical methods are very important tools now. In numerical methods, we use that is called as iteration process. What is iteration process? Iteration means repeated. The same process is repeated in each step. Same process is repeated in each step. Iteration means repeated steps. Repeated process or repeated steps. Here we use, in calculating the one step, we use the value of the preceding step. Value of the preceding step. So in this way, by applying the same process and taking the value of the preceding step, we get the accurate value. This is called as numerical method. In this method, for engineering mathematics 2, we have two methods are there. One is Regula Falsi method and other one is Newton-Raphson method. One is Regula Falsi method, or it is also called as false position method, or it is also called as false position method. Both are same. Second method is Newton-Raphson method. Newton-Raphson method. It is also called as NR method. In shortcut, it is also called as NR method. So, for your syllabus, these two methods are there. These two methods are used to find the solution for algebraic equations and transcendental equations. Algebraic and transcendental. What is algebraic? Algebraic means equations containing x, x cube, x square plus 4x, like that. These are called as algebraic equations. Transcendental equations means equations containing logarithm term, trigonometric term, metric term or exponential term. These are called as etc. These are called as transcendental equations. So by using these two methods, we can find the solutions or we can find the roots of the equation of algebraic as well as transcendental equations. Now we'll study what is Regula Falsi method or false position method by taking one example. Before that, one rule is there, that is, if we consider one interval a, b. So interval means this is a real number line. This, suppose we take a here and b, this represents interval. We say that one root x1 is said to lie in this interval only if suppose f of x is given function. It may be algebraic or transcendental. It is a general rule what I am explaining. So f of x is one equation. What we have to do? First we have to find out f of a is equal to, we will get one value. It may be positive or negative. Then we have to find out f of b. Again we get one value. Then we have to check whether x1 lies in this interval or not. For that one, we have to find out f of a into f of b. If this product is negative, that is less than 0, then we say that this x1 lies in this interval. Then f of a, if it is positive and it is negative, or it may be, this may be negative or this may be positive, but condition is one should be positive, one should be negative. Then in this interval this x1 lies. And again, if we take the nearer values, this interval goes on decreasing. So if you take more number of iterations, then we'll get the very small interval here. So this is about Regula Falsi method or false position method. Let us take one example on this. Let's solve examples based on the Regula Falsi method. Students, I suggest better you take one pen, pencil and calculator. Be ready with this so that it is easy to understand, and if you solve with me, then you will become perfect in this procedure. So let us consider one example, that is x cube minus 2x minus 5 is equal to 0. This is given example. What we have to write? First write down f of x is equal to x cube minus 2x minus 5. This is algebraic equation. What we have to do, as I have explained now, we need to find out the interval. That is, to find the interval, we have to check f of a into f of b less than 0. So how to find out a and b? To find out a and b, we have to start with 0, 1, 2, 3 or minus 1, minus 2, minus 3 like that. In such a way that we should get one f of a positive or negative, another should be negative or positive, so that their product becomes less than 0. For that one, we'll start with 0, f of 0. What we'll get here? If you substitute x equal to 0 here, we'll get minus 5. Next, substitute 1. What we'll get here? It is 1 minus 2 minus 5. Again it is minus 6. Next, this is also minus and this is also minus. So I cannot take this as the interval because both are minus. Check next one, f of 2. What we will get here? 2 cube minus 4 minus 5. Answer is minus 1. Minus 1. Again it is negative. Next consider f of 3. What we will get here? It is 3 cube minus 2 into 3 minus 5. It is f of 3 is 16. F of 3 is 16. You can do this with calculator also. Now check. Here I have minus 1 and here it is 16. So one is negative, one is positive. Stop here only. We'll get the interval, that is 2, 3. Always write down the smaller first and then bigger one, because always interval is denoted like that, smaller to bigger. Now root lies in this interval. First our job is to find the interval. So f of a, f of b, interval ab. Okay. Why we have taken? Again I want to make it perfect. That is why we want to take f of a into f of b less than 0. If it is the condition, then root lies in that interval. Here one is negative, one is positive. It implies root lies in this interval. So interval is 2, 3 where root lies. This is our first job. Root lies. So here a is equal to 2 and b is equal to 3. Then f of a means already we found. F of a is f of 2. F of 2 is minus 1 and f of b, that is f of 3 is 16. Write down all the terms clearly. Then write the formula. So by Regula Falsi method, formula is first iteration formula is x1 is equal to a f of b minus b f of a divided by f of b minus f of a. This is the formula for Regula Falsi method. So first we will find out first iteration, that is x1, by substituting all these values in the formula. For that one, first let us substitute these values in the equation, in the formula. So x1 is equal to, it is a is 2, f of b is 16 minus b, f of a is minus 1 divided by f of b minus f of a. This is the formula. So just substitute in this and answer will be, just you also try, answer will be 2.05882. This is our x1, that is x1, write it clearly, 2.05882. this is x1. It completes one iteration. As I have told, in numerical methods we follow the iterative procedure. What is iterative procedure? Same process is applied in the next step, but in next step we take the value of the preceding step. Only you have to follow that. One iteration is over now. Now we will take second iteration. So for second iteration, what we have to find out? First find out f of x1. So f of x1 means in the given equation was f of x is equal to x cube minus 2x minus 5. In this equation substitute 2.05882. X is equal to 2.05882. You will get, just substitute here, 2.05882 cube minus 2 into 2.05882 minus 5. Answer will be minus 0.3908. You also check the answer. So this is negative. Next, what we have to do? We have to take the interval. How to take interval? Again, one positive, one negative. For that one, for a better understanding, I'll write a, b, x1. A is 2 and b is 3 and x1. Now we got it. 2.05882 and f of a is, f of 2 is minus 1 and f of 3 is, f of b is, what is f of b? F of b is 16 and f of x1, we have got it, minus 0.3908. These three you have to consider, and out of these three you have to take one positive and one negative. See here, f of b is positive, f of x1 is negative. We have to conclude that root lies in this interval. You cannot take this because it is negative. So one should be positive, one should be negative. So we conclude that root lies in the interval. The root, you have to write it clearly, root lies in, always write down smaller one first, 2.05882, 3. You have to write it clearly, 2.05882, 3. So here our new a is, this is a and this is b, and f of a will be, this is f of a and this is f of b, and formula will be same. Only here we have to write x2. x2 is equal to, this x1 becomes x2 and it is second iteration value. So x2 is equal to a f of b minus b f of a divided by f of b minus f of a. We will substitute here. x2 is equal to, our new a is 2.05882a, and f of b, that is f of b is 16 minus b, f of a is minus 0.3908 divided by f of b minus f of a, and answer is, calculate, answer is 2.05882 into 16 minus 3 into minus 0.3908 divided by 16 minus 0.3908. In one step you can calculate by using calci. Put brackets here for easy calculation and avoid silly mistakes. You will get x2 is equal to 2.0813. So x2, write it in block, highlight your answer always. x2 is equal to 2.0813. Just observe here, this is our x1 and we have taken here root lies in the interval 2, 3. Just why we are taking iterative process, just I will make it understand. So here it is 0. First, what we concluded? Root lies in the interval 2, 3. Then, or else I will take like this. This is the interval 2 and 3. So, first we have taken root lies in the interval 2, 3. And what is our answer? It is somewhere here. 2 point, this is x1. So, it is our new interval. We are getting little bit closer interval or small interval. This is our x1. Whatever answer you will get, that x1, it should lie in this interval. Suppose your answer is less than 2 or greater than 3, then it is wrong. Always check your answer whether it lies in this interval or not. Next, what is the answer? x2 is 2.08. This is 2.05 and 2.08. So here, this is x2. Always it should lie in the interval. Then only your answer is correct. So 2.0588 to 3. So here it lies. Our new interval is like this. So if you go on taking the iterations, you will get the correct, accurate value. Now for each problem, better you take minimum 3 iterations. Let us take third iteration. For that one, you have to find out f of x2. This is third iteration. F of x2, that is, substitute this in this given equation, 2.0813 cube minus 2 into 2.0813 minus 5. Calculate this. Its answer is minus 0.1473. Now it is f of x2. Again we have to find out the interval. For that one, a, b, x1, x2, then f of a, f of b, f of x1, f of x2. Once you practice the problems, it is not required to write down all these. Easily we will get to know the interval. So what is f of a? F of a is minus 1. F of b is 16. F of x1 is minus 0.3908. F of x2 is minus 0.1473. So again observe here, this is negative, this is also negative. We cannot take negative. So this is positive. We can take this one as our new interval. So we that the root lies in the interval root lies in, what is x2 here? x2 is 2.0813 and b is, it is 3, 2.08133. So our new root lies in this interval. For third iteration, again same formula. Here what is a? A is 2.0813, b is 3, f of a, that is f of 2.0813 is minus 0.1473 and f of b is 16. Now x3 is equal to, again formula is same, af of b minus bf of a divided by f of b minus f of a is equal to a is 2.0813, f of b is 16 minus 3, f of a is minus 0.1473 divided by f of b minus f of a. Calculate it and answer will be, x3 will be 2.0897. This is x3. So our values, just I will write here, x1 is 2.05882 and x2 is 2.0813, x3 is 2.0897. Always these values will be very near, and you won't get one value 2 point something, other value 3, then definitely it is wrong. Your values should be very near. Then finally you have to write, therefore the root is whatever answer you will get in the third iteration, that you have to write. That is a better approximation. So in this way you can continue to get the accurate solution. This is one problem. Let us consider next problem. Let us consider next example, that is x log x to the base 10 minus 1.2. Always you have to check whenever logarithmic function is there, you have to check this base. If base is given, then 10 is given, then in calc you have to take log. If base is not given or if base is given as e, you have to take ln. This is very important. If you take here log to the base 10 is there, if you calculate by taking ln, then definitely problem will be wrong. That you have to please remember, that log and ln, that is the difference. So again what we have to do, by using Regula Falsi we have to solve this problem, or we have to find the root of this equation. First step is, always write down f of x is equal to x log x to the base 10 minus 1.2. We have to find out the interval. For that one, again put x equal to 0, 1, 2, 3 like that, to get one positive and one negative. For that, first I will check f of 0. We will get, if you put x equal to 0 here, this will be 0 minus 1.2. Then substitute f of 1, that is x is equal to 1. Here 1 log 1 is 0. Again we get 1 minus 1.2. Then take f of 2. Substitute x is equal to 2 here. 2 log 2 to the base 10 minus 1.2. Check this value. It is f of 2 is equal to minus 0.5979. Better you also calculate. Then again this is also negative, this is also negative. We cannot take the interval. Take f of 3. Substitute x equal to 3 here. 3 log 3 to the base 10 minus 1.2. Calculated. Its answer is 0.2314. It is positive. Now we can stop. One is positive and this one is negative. So root lies in the interval 2, 3. because f of 2 into f of 3 is negative. One is negative, one is positive. Here only you stop. You cannot take this one positive and this one negative, because always consider the interval nearer one. This one is also correct, you may get the answer, but you have to take more number of iterations. For that one, always take nearer values. Actually, there should be 0.1 difference only, but here we will take 2, 3 and we go on iterating it. So root lies in the interval 2, 3. Okay, so A is equal to 2, B is equal to 3, f of A, that is f of 2 is equal to minus 0.5979, f of B is equal to, that is f of 3 is equal to 0.2314. First iteration, Regula Falsi method. What is the formula? x1 is equal to A f of B minus B f of A divided by f of B minus f of A. We'll substitute these values. A is 2, f of B is 0.2314 minus 3. Okay, A f of B minus B f of A 0.5979 divided by f of B. F of B is 0.2314 minus f of A. F of A is minus 0.5979. Calculate it. Its answer is x1 is 2.7209. 2.7209. x1 is equal to 2.7209. Just check whether this answer lies in this interval or not. 2, 3 is the interval. 2, 3 and 2.7209. Somewhere here it will come, or somewhere 7 means here. 2.7209. So root lies in this interval. So our answer is correct. Next we will take second iteration. Second iteration. Again we have to find out the root, the interval. Before that we have to find out f of x1. F of x1 is equal to, in this equation substitute 2.7209. 2.7209 log 2.7209 minus 1.2. So f of x1 is, it is f of x1 is equal to minus 0.0172, minus 0.0172. Again we have to check the interval. What is A? A is 2. F of A is minus 0.5979 and f of B is 0.2314. F of x1 is minus 0.0172. Just observe this. This is our f of x1 and this one is positive. So we can consider this as the interval. So root lies between x1 and B. You cannot take this, as I have told, as I have explained. Root lies, therefore the root lies, x1 is 2.7209, root lies in the interval, and B is, that is B is equal to 3. Root lies in this interval. This is our second interval. Next we will find out the root, new root, that is x2. So x2 is equal to A f of B minus B f of A divided by f of B minus f of A. That is same formula. So this is A, this is B. So A f of B and f of A is, that is f of 2.7209 is minus 0.0172 and f of B, that is f of 3 is, f of B is it is 0.2314. F of B is 0.2314. Now we'll find out x2. x2 is A, that is 2.7209. F of B 0.2314. I'll write here minus B is 3. F of A is minus 0.0172 divided by F of B minus F of A 0.0172. So calculate this. x2 will be 2.7209 into 0.2314 minus 3 minus 0.0172 divided by 0.2314 minus 0.0172. What is the answer? Answer is 2.7402. So x2 is equal to 2.7402. Again check this, whether it lies in this interval or not. Yes, 2.72 and 2.74. Then definitely 2.74 will come here. It lies in that interval. Then our answer is correct. Next we'll take third iteration. For third iteration, we have to find out f of x2, third iteration. Find out f of x2. F of x2 is equal to, again substitute 2.7402 in this equation. Answer, that is, I'll write again 02 log 2.7402 to the base 10 minus 1.2. Its answer is f of x2 is minus 0.00038. So again this is negative. F of x2 is negative and f of x1 is, that is also negative. So you cannot take f of x1, x2, x1 and x2. So we have to go back, that is we need to consider f of b only, or else I'll write here f of a, f of b, f of x1, f of x2, and f of a is minus 0.5979, f of b is 0.2314, f of x1 is minus 0.0172, f of x2 is minus 0.00038. So these two both are negative, so you cannot consider these two. If it is negative, we have to go back, and whichever is positive, that we have to consider. So this is positive. Therefore root lies in this interval x2 b. What is x2? x2 is 2.7402 and b is 3. So root lies in the interval. Root lies in the interval, that is x2 2.7402 and 3. Now we will find out, that is x3. So a is equal to 2.7402, b is equal to 3, and f of a, that is f of 2.7402, f of 2.7402, it is minus 0.00038, and f of b, that is f of b is 0.2314. 0.2314. Now we'll find out x3. No need to write down the formula again and again. If you write it in the first iteration, then it's okay. So don't waste your time by writing the formula again and again. x3 is equal to a f of b 2.7402 minus into 0.2314 minus b f of a 0.00038 divided by f of b minus f of a. Answer is, calculate it. So x3 is equal to, it is 2.7406. 2.7406. This is x3. Again check whether this root lies in the interval or not. 2.7402, it is 2.7406. Definitely it lies in this interval. So our answer is correct. Finally, you have to write all the roots and one final answer, that will be your third iteration value. So the root of the given equation is, x is equal to 2.7406. This will be your final answer. Let us consider next example, that is on trigonometric function. So now third example is cos x is equal to x e raised to x. Here trigonometric function is there. When trigonometric function is there, first observe the equation. If trigonometric term is there, then keep your calci in radian mode. That is very important. If you calculate it directly, then definitely your answers will be wrong. So trigonometric term is there, then keep your calci in radian mode. Solution. First we have to take f of x is equal to cos x minus x e raised to x. I hope you have kept your calci in radian mode. Then again we have to find out the interval. F of 0 is equal to, it is 1, cos 0 is 1 and this will be 1. F of 1, so calculate it. F of 1 is minus 2.18, minus 2.18. So here 1 is positive, 1 is negative. So root lies in the interval 0, 1. Root lies in 0, 1 in this interval. Next, by Regula Falsi method, first iteration. What is the formula? Write on the formula here. x1 is equal to a f of b minus b f of a divided by f of b minus f of a. So a is 0, b is equal to 1 and f of a is 1 and f of b is minus 2.18. x1 is equal to a, it is 0, so anyhow it will be 0, minus b f of a, it is 1, divided by f of b minus 2.18 minus f of a. Answer is 0.3145. So x1 is equal to 0.3145. Interval is 0 to 1. 0.3145, it lies in this interval. Interval is 0 to 1. 0.3 somewhere it will be here, 0.3. So it lies in the interval. So our answer is correct. This is first iteration. Let us take second iteration. Before solving second iteration, we have to find out f of x1. F of x1 is equal to, it is 0.3145 cos 0.3145 minus 0.3145 e raised to 0.3145. E value you will get by shift ln. E will come. Just check in your calci. Cos 0.3145 minus 0.3145 shift ln 0.3145. You will get the answer. So f of x1 is 0.5202. 0.5202. Now we'll find out the interval. For finding the interval, again I'll write here f of 0 is equal to 1 and f of 1 is minus 2.18. So next we find the interval, and f of x1 is 0.5202. So f of a is 1, f of b is minus 2.18 and f of x1 is 0.5202. So this is positive, this is negative. So root lies in the interval x1 b. What is x1? 0.3145 and b is 1. Root lies in 0.3145 and 1. Next x2 is, so I'll write again, a is equal to 0.3145, b is equal to 1, f of a is equal to 0.5202, f of b is equal to minus 2.18. So x2 is equal to a f of b 0.3145 into minus 2.18 minus b f of a 0.5202 divided by f of b minus f of a. Answer is x2 is equal to 0.4466. This is x2. Second iteration. Now we'll take third iteration. For taking third iteration, first we'll find out f of x2. F of x2 is equal to, just substitute x2 is equal to 0.4466 in the given equation. So f of x2 is 0.2039. You also check the answer, 0.2039. Then now f of a is 1. I'll take here only, anyhow it is written. So f of a is 1, f of b is minus 2.18, f of x1 is 0.5202, f of x2 is 0.2039. So we have to take one positive, one negative. So this is positive and you can't take this, so we have to take this one. Root lies in the interval x2 and b. So therefore root lies in what is x2? 0.4466 and b is 1. Root lies in this interval. Now our a is equal to 0.4466, b is equal to 1, f of a is equal to 0.2039, f of b is equal to minus 2.18. So x3 is equal to a f of b minus b f of a divided by f of b minus f of a. Answer is, even I am writing 1 also here, just when you refer this you will understand, because b is 1, that's why b is equal to 1 I have written there. Its answer is x3 is equal to 0.4466 0.4752. x3 is equal to 0.4752. So x1, x2, x3. Then final answer, therefore root of the given equation is x is equal to 0.4752. This is the final answer. Sometimes in a regular falsi method they may give example like find the fourth root of 32. Find the fourth root of 32. In like this also they may give fourth root of 32. In such cases what we have to take, x is equal to, let x is equal to 32 raised to 1 by 4. We need to find out fourth root. So we can write 32 raised to 1 by 4. If you raise to the power 4, x raised to 4 is equal to 32. Your f of x will be x raised to 4 minus 32. Again same way you can solve the example. They may give fifth root like that also. So let me summarize this, what is a regular falsi method, what mistakes we do while solving the example and all. Just I will summarize in 1 minute. That is, first of all we have to find out interval. Finding interval, as I have told you, always f of a into f of b must be less than 0, that is negative. Next write down interval ab. Then formula is x is equal to a f of b minus b f of a divided by f of b minus f of a. Take minimum 3 iterations and up to 4 decimals. Your answer should be up to 4 decimal points. So take first iteration, second iteration, third iteration. After each and every iteration, check your answer whether it lies in that interval or not. That is very important. Compare your answers and avoid calculation errors and silly mistakes. And if log to the base 10 is there, take log in calci. If log to the base e is there, then take ln. If trigonometric term is there, then keep your calci in radian mode. These are the few important points to be remembered while solving regular falsi method problems. And final answer, you have to write one answer, that is x is equal to. If you find out 3-4 iterations also and not writing the final answer, you may not get full marks. So always write down final answer, x is equal to. This completes regular falsi method. If you like it, then like, comment, share and subscribe my channel. Thank you.